I'd like to introduce Dr. Kai Rains from the University of South Florida. Um, Dr. Rains is a research associate professor at USF and the Secretary General of the Society of Wetland Scientists. So this is going to be a great presentation. She studies ecosystem response to environmental stress, including nutrient limitation and global change. And her research runs the gamut from organismal level, such as root mycorrhizal associations, to the entire landscape, um, including the use of geospatial tools, which you'll probably see in this presentation, with a focus on waters and wetlands. So with that, it's my great pleasure to introduce Dr. Kai Rains. And I will, Kai, I'm going to just stop my sharing, and then that'll enable you to share your screen.
All right, let's see if I can pull off the sharing part. And does that look?
There you go.
That looks good.
I've seen the test slide, but it looks great.
All right.
That's perfect.
Okay, well, I don't use Zoom very much, so I'm saying I'm starting off with a real win here. Thank you for the invitation, and thank you to everyone who's choosing to spend their lunch hour with me. I appreciate it. I'm going to be speaking, just a second, sorry, there's something wacky here. There we go. I'm going to be breaking this talk into two parts. In the first section, I'm going to be talking about mapping the transformation of hydrologic resources, specifically in St. Lucie County, where we've been working for a while, through time. Then in the second portion, I'm going to be focusing on how we've used the insights gleaned through this work to design and build a tool for conservation planning. So I am coming to you from the Ecohydrology Research Group, which I co-direct with my husband, Dr. Mark Rains. Excuse me. We are both professors in the School of Geosciences at the University of South Florida, where we have both undergraduate and graduate student researchers, and much of the work that I'm going to be presenting today is a result of their labors. So I want to start off by talking a little about the pressure that Florida is under with respect to population growth, both now, which we probably all experience today, but also historically. So the figure you're looking at here has the population of Florida on the y-axis and the year in 50-year increments on the x-axis. And what you'll note is from 1850, about the time Florida achieved statehood, to, let's see what, I am getting used to the chat thingy is coming up. In 1950, the growth in population was pretty slow, but then it really took off in the 1950s. And really what we've looked at since then is a net increase in 750 people per day since the 1950s. You add on to that our astounding rate of visitation, 140 million in 2022 alone, and it's no wonder that we're seeing a lot of change in our landscape, and that's what I want to talk to you about today. So back in the day, before all these people, much of peninsular Florida would have looked like this: vast, extensive wetlands. Due to how flat we are, very few channels. Instead, this is the landscape that much of us are much more familiar with, or many of us are much more familiar with. A loss of wetland resources, artificial water features, variously connected with channels, many of them actively pumped. Before I go further, because my focus is going to be on wetlands, I just want to kind of get our minds back into why we might care. What is it that happens in wetlands? Of course, there's a lot of habitat benefits, a lot of wildlife, unique plant species, a lot of species I'm sure we haven't even discovered yet, microbes happening on the surface. We've also got amelioration to the temperature. So, cooler in the summertime, warmer in the wintertime when you're near a wetland. There's a lot happening below the surface as well. So this water that's stored on the surface over time infiltrates into the soils, replenishing the aquifer, adding that surge of fresh water that's going to inhibit saltwater intrusion and be available for our use later on. And then waterlogged soils, saturated soils also produce or have the ideal conditions for chemically improving our water quality. So, nitrogen, phosphorus, real common pollutants you hear about in water if they're present in excess. When you've got water, when you have a wetland that intercepts polluted water, there is a chance for that nitrogen in particular to be converted to a gas and actually leave the water cycle, leave the water altogether, go back out into the atmosphere where it belongs, and thus keep the downstream waters from potentially forming algal blooms. So there's a lot going on in wetlands, and as we've lost them, we've lost a lot of our natural capital, our ability to perform these functions and provide these services. So about 10 years ago, we completed, our group, the Ecohydrology Research Group, completed a small wetland project with St. Lucie County, which enabled us to become familiar with the county. And we also formed a strong collaborative relationship with the St. Lucie County Environmental Resource Department. Through this, we became interested in the history of hydrogeological change in the county, particularly in light of declining water quality in the Indian River Lagoon. So we set out to investigate where hydrological change has occurred, both in terms of changes in wetland area, wetland distribution, and in terms of increased connectivity between the water resources in the county through these increases in channelization. Ultimately, we were interested in using these insights to enhance conservation planning, but first we needed to know where things had happened. We needed to do some mapping. So specifically, I'm going to be focusing on how much area has been lost, where has it been lost, how much channel length has been gained, and where has it been gained. We set our baseline conditions all the way back to the 1850s, so the beginning of that population figure that you saw. This was really when Florida achieved statehood at about that time. It was also a time when there was a concerted national effort to survey lands. These surveys were conducted by people who would walk along a strict compass bearing and chart their progress through this use of this metal chain that you see here that would be a specific length, 66 feet. And then they would take detailed notes about what they encountered along that length. This took some time, as you might imagine. In St. Lucie County alone, there were 7 different lead surveyors over the time it took to survey the county, and it took about 16 years. So, of course, this took place not just in St. Lucie County, it took place in much of Florida and the United States in general. So what we did with these resources was we acquired reproductions of the 18 St. Lucie County maps produced from these surveys. And that's what you see in front of you there. Each one of those letters and numbers are the labels of the township of the maps themselves. We georeferenced them so that we could work with them digitally. And we looked over these maps. We looked over the notes associated with the maps to create maps of the wetlands and the channels in the 1850s. If I blow up one component of the map, that one there in the southwest corner, this is what you're looking at, or this is what we had to look at. And you can see, really detailed hand-drawn images, the word prairie written across it, corresponding notebook pages, and those lines that form that checkerbook pattern are the lines the surveyors actually had to walk. And sometimes, as you can imagine, that walking wasn't super easy. Here's a page out of one of the notebooks produced by the surveyors, and this one's from Lee County. We see to round pond surrounded by bay and cypress swamp impracticable. Pond full of monstrous alligators, counted 50 and stopped, relinquished the line. So, conditions were tough, but they've left behind a really great resource, which we have been able to use to map St. Lucie County. I'm going to skip pretty quickly now to the results, but if you're interested in learning more about this, I encourage you to look up our publication in Wetland Science and Practice. It's a free access Society of Wetland Scientists publication. It was published in October 2023 and that talks about what we learned along the way in much more detail. It's written for an informed but general audience. So it's easy to follow and it's short. Okay, so we started, we had this base map that we had gotten together from the 1850s. We also put together a whole series, hundreds of aerial imageries from the 1950s that were available to us in black and white. And we georeferenced those, and then we're able to compile a map of wetland distribution and channels in the 1950s. Then finally, we were able to rely on publicly available resources from the Water Management District to see what the current conditions were. Once we had really extracted the wetland and channel features from each of these various components, we were able to look at the change in the hydrological resources in detail in St. Lucie County over time, over this time span. So what did we find? Well, so what you're looking at right here is a map of the mainland portion of St. Lucie County. The barrier islands are in outline, but they weren't part of our study area. Everything that is green was a wetland in the 1850s. So vast majority of the county mainland was a wetland in the 1850s. Now I'm gonna show you what it's like today. And again, and it will also be in green. So we go from this in the 1850s to this today. Very few wetlands. We've lost a lot of our natural resources. In fact, the wetland loss has been more than 85% in the county from the 1850s to the 2020s, with a lot of that happening from the 1950s to current day. We did a similar analysis looking at channels. In this case, the way we're going to quantify our channels is using channel density. So we mapped the channels in the 1850s, which is what you're looking at here. And then we figured out the length of that in kilometers and divided that length by the area of the county to get channel density. So it's kilometer over kilometer squared. And that's what I'm going to keep referring to as channel density now. So you can see very limited channel density in the 1850s. And I'm sure you can suspect the situation has changed today. All right, so this is what we're looking at today. Again, the channels are mapped in blue. The thing that looks like one big ocean there in the northern section of the county is actually just highly detailed channel mapping work. So we went actually from a channel density of 0.8 kilometers per square kilometers in the 1850s to around 25 kilometers of channel length per square kilometer in the county as a whole. Our drainage density has increased 30,000%, so 300-fold between that time frame. Much of it, again, since the 1950s. When we look at these, I'm going to look at all this together and sort of stop and think for a moment. So we have, again, the wetland distribution in the 1850s versus current day. In the 1850s, if you were a raindrop falling in St. Lucie County, you had a very high chance of falling in a wetland itself. And we know St. Lucie County is quite flat. So chances were you weren't going to go anywhere, particularly with the very limited amount of channel density in the county at that point. Instead, you were going to infiltrate down into the soils or evapotranspirate back up into the atmosphere itself. However, today we're going to have a very different situation. So let me quantify that before I move on. So in the 1850s, 2% of the total county area was within 100 meters of a channel. Within that 100-meter buffer, if you will, 85% of that was a wetland. So channels were pretty highly protected. Today, we've got 85%, kind of confusing, it's the same number, but that's what it is, of the county is within 100 meters of a channel. Within that 100-meter buffer, only 9% of that is a wetland. So much less protection for our, well, right now I'm thinking of the rivers. So if you are a raindrop falling in St. Lucie County right now, you have a much higher probability of being shunted elsewhere. The channels are designed to move water, so you're going to fall, and chances are you're going to go somewhere. If somebody just showed me these images and I knew nothing about St. Lucie County, and they wanted me to guess as to the water quality in the downstream waterway, in the receiving body of water, I think all of us could guess, if put in that situation, could guess pretty quickly that that water quality has probably suffered some impacts when we have changed our hydrologic landscape so significantly from what it used to be. So there's a lot of motivation now, as you appreciate these sorts of insights. There's motivation for conservation of our mining resources, both in terms of restoration of our landscape as well as preservation. But clearly we can't go all the way back. We can't go all the way back to the 1850s. We can't even go back to the 1950s. So where do we put our resources? Where do we prioritize? Well, it was that sort of question that led us to develop the geospatial tool, which we call CREST, which is what I'm going to talk about next. So CREST is a geospatial tool. We have co-produced it with stakeholders, which just means we've asked for a lot of feedback along the way. We've particularly taken advantage of our collaborative relationship with St. Lucie County, and then the Indian River Lagoon National Estuary Program has offered a lot of feedback as well, or facilitated it. We had some goals as we developed this tool. We wanted it to be objective and transparent, no like weird coding in somewhere. We wanted it to be user-driven, for there to be a flexible query system, so a variety of people could use it. We wanted it to be easy to use, minimal technical skills. And we wanted to rely on a proven format if we could, something peer-reviewed, something people would have faith in. So luckily we had some resources to draw on. Several years ago, we'd worked in collaboration with the Tampa Bay Estuary Program to help develop a geospatial tool for prioritization among opportunities for wetland mitigation, and really to help them develop a mitigation plan, a wetland mitigation plan. And those, we published it in peer-reviewed journal. It was incorporated into some important planning documents and won first place from the Tampa Bay Regional Planning Council. So we knew we went into this current effort with CREST kind of thinking, all right, we're going to work off that platform. That'll kind of be our launching point. But we knew we needed to update it, and we knew we needed to regionalize it. The Indian River Lagoon watershed is not the Tampa Bay watershed. So in order to do that, we wanted to work closely with our stakeholders. The development of the tool itself, okay, this is going to involve a little jargon, but we'll get through it quickly. First, we needed to select the assessment unit size, and that'll make more sense in a second. We needed to identify the information required by decision makers. What are people currently, what information do they use to make conservation decisions? And what information do they wish they had? We want to acquire and cleanse the corresponding geospatial data sets, getting rid of any weird anomalies. And then we needed to analyze the data and develop something called screening layers, which I'm going to show you, and then design a user interface. Today, where we're at is that fifth step. So we've completed CREST. We need to put some finishing touches on the user interface, and then we'll be done. Okay, so the assessment unit, as I said, was the first thing we tangled with, and we did so with our stakeholders. This was a good example of their feedback being important. We knew we wanted to view the results at a landscape scale. We wanted to be able to assess the county as a whole. But we learned through conversations with our stakeholders that, they know their county. They don't need to know a specific spot. And in fact, it would be advantageous not to single out specific parcels when we return the results. So it was perfectly acceptable to have our assessment unit be on the larger side. So we settled on 1 kilometer by 1 kilometer grid cells. And what you're looking at right here is the map of the mainland portion of St. Lucie County with that 1 kilometer by 1 kilometer grid cell net, if you will, superimposed on top. And you're going to see the same pattern in the slides that follow. So I want you to be comfortable with what this means. I've mentioned stakeholders a couple of times. We also do a lot of work in Alaska. We do a lot of work with stakeholders too. It's kind of the fun part of our job is learning from others. So we spent some time talking and listening, excuse me, to a variety of people. Just a few are listed here. Some of these conversations have been very important for us for discovering or understanding what information is needed for decision support. And the ones that we have really keyed in on are listed in that dark blue column in the center. Current wetland distribution, where are they? What's their condition? Would the general landscape around the wetlands be supportive of conservation efforts if we sunk some money into that? Where have wetlands been lost? Where have we lost natural capacity? How far is it to land already conserved? It turns out there's a lot of interest in maybe, having some partnerships or establishing corridors, as long as you're thinking about conservation issues. How hydrologically connected is this landscape? Is there opportunity for maybe some restoration of canals, or, how does water move through this landscape? And when and where is development likely going to happen? Where are high-risk lands that if we don't grab them now, we're going to be in trouble? So for each of these, we had to find a corresponding geospatial data set, and those are listed on the right-hand side. We really tried to stress ones that were well known, publicly available, particularly preferably statewide, because we had hoped to expand this tool. If people liked it, we wanted to be ready to pivot. The step after we identified the data set, what we needed to do was to turn the data set into a screening layer. So I'm going to go through development of a screening layer next. I'll just go through one, and then that'll help you understand the way the tool is designed. In this case, you're looking at that aqua blue is the current distribution of wetlands in St. Lucie County. And then we have that 1 kilometer by 1 kilometer grid layer superimposed on top. The reason we call those an assessment area is because what we're doing next is we're asking how much area of each grid cell contains wetlands. So we're assessing it per each one of those grid cells. Then we use those results to classify the grid cells into 5 categories. So we move from a percent area to 5 categories. And those 5 categories are just a 1 through 5, most favorable to least favorable, in this case, simply based on the presence of wetland. So if you flip your eyes back and forth, you can see that, oh yeah, the really green ones do correspond to where there's a bunch of wetlands. Pretty straightforward. But it enables us to use the metrics hierarchically. Well, you'll see in a second. I'm going to run you through it first. So we did this same process for each one of our 8 metrics, which correspond to those questions that I showed you in that dark blue column slide or 2 ago. The color coding here is the same for each one. That is the most favorable condition is in dark green, and the least favorable is in the red. You'll note that next to those, in addition to having the color in that legend that just popped up, it also has the numbers 1 through 5. So when we're looking at it in the map, it's very handy to be able to see, depicted in the colors, where's the most favorable, where's the least favorable. But for actually running a query, that's when we're going to focus in on the numbers. So anchor in your head that 1 dark green, favorable, 5, least favorable. So how do we use this tool? Let's say that you were going to run a preservation query. You just wanted to know, hey, where, well, you know, across the whole county, where might be some good candidates for preserving wetlands? In that case, you probably want, so I've got, you don't have to use all the screening layers at once. You can sort of pick and choose what you want to use. I've just decided to use only 5 of the 8 in this particular query. And I've set the query to particular conditions. So I want our particular settings. So I want tool to return to me locations where the wetlands are in really good condition. 1, landscape condition is really good. It's going to be supportive of that preservation for quite some time. I want there to be wetlands, so something 1 to 3. I don't want the land to be super expensive. So I'm looking at development hotspots kind of in the future, hoping that, you know, the price hasn't gotten up yet, but I want areas that are at risk. So I'm going to give that a 3 to 5. And I want something new, something that doesn't have conservation lands in it yet. So something more than a 1. In that case, the tool returns for me the grid cells that are outlined in aqua blue. So those are ones that fit the conditions of the query. Zoom in on one, take a look at it. Everything you see that's sort of that dark color is water. And then that kind of brownish color corresponds to wetlands. So sure enough, this is an area with wetlands that isn't highly developed, and it might be an area where, you know, I should look into it a little better or a little more in depth and see what's going on there. Maybe that is an area where I want preservation. So that's an example. I want to run you through another example, which is what if instead I wanted to identify lands for restoration? Well, I might have a very different query, and you'll see that some of the screening layers have changed, and certainly the values that I'm looking for has changed. So wetland loss, where we lost some wetlands, where wetlands in kind of middling to poor condition. Again, I'm looking to do a restoration, so I don't want my perfect wetlands. I do want there to be some wetland area, but you know, I'm open as to how much. And landscape condition, however, I want that to be pretty good, because if I'm going to sink my restoration dollars into that area, I want to make sure that the landscape around it can support it. Very different set of grid cells light up. We zoom in on one and we see a different type of setting, that one that sure enough looks like it could use some help, some restoration. So that's one way in which this tool can be used, where you are truly just sort of sitting back and thinking, okay, where are my best opportunities? Well, we gave an early draft of the tool, or just sort of as we were working along with St. Lucie County, they were interested in what insights this tool could provide for some projects they had going on, or some proposed projects, or just something they were thinking about. And so we tried applying the tool to those sorts of scenarios, to evaluating different previously identified conservation targets. And so now I'm going to show you 2 of those types of examples. In the first setting, the county was interested in proposing, and I believe the Water Management District as well had interest in proposing those parcels that are outlined in red as candidates for the Florida Forever program. And so we took a look at, how they showed up, or what our tool could say about them. And the 2 metrics, the 2 screening layers that I'm showing you here on the screen, are now zoomed in versions of the results of the wetland of those parcels intersected with the wetland condition screening layer and the landscape condition screening layer. In both cases, you see that the parcels are intersecting pretty nice areas. And so we were able to generate a sentence that the county included in their application. namely that current condition of supporting landscape and wetlands is amongst the best in the county, indicating a high potential for successful wetland preservation and channel restoration activities. I've spent, I guess, most of this talk, I've been talking about the wetlands that are far from riverine environments. So I want to show you another example where we ran some potential restoration areas proposed by the county through this tool, but in this case, we were right next to a river. So this was in anticipation of an Army Corps of Engineers visit, and we're just kind of looking at what are the differences of some of the proposed restoration areas. So I've got one with a red circle, and that's exactly what I'll call it, the red circle area. And the yellow one with the blue circle, I'm going to call the blue circle area. We looked at a few of our metrics. In this case, channel density was a particular interest because we are in a river area that has some development nearby, and then also development at hotspots. We wanted to see what was going to happen, what was likely to happen in the future. And what we could tell, or what we noticed between these two different sites, was that the blue circle site is in a landscape with higher channel density. And you can even see that with, all the houses nearby, resulting in greater off-channel hydrological connectivity. So it's going to get a lot of stormwater presently. However, the red circle site is immediately downstream of lands expected to undergo development. And this proposed restoration could mitigate future increases in stormwater runoff. So if you look down at the development hotspots, where I'm zoomed out a little bit, that's why the grid cells look smaller, so that you could see the surrounding landscape. You see that there is some reds and oranges and yellows for development hotspots, indicating that those areas are likely to develop quickly. So this was two ways in which you could use the tool to evaluate potential restoration sites. We gave the tool to the county, and they had various people try it out. And then we did a survey asking them what they liked about it. And one of the responses we got, and also what they didn't like about it, which is why we're still working on the user interface. One of the sets of feedback we got really spoke to the advantage of having a very flexible tool like this one. So the ability to pick and choose which attributes are most important for the intended query is extremely helpful, as each grant opportunity or restoration goal may have different needs and targets. And just as in this case, it's a single person talking about a variety of potential grant opportunities or restoration goals, but we're hoping that this tool will also serve many different people who are, managing with different goals themselves. So a cross section of decision makers. So with that, I am concluding. I guess we started this journey, this talk, by looking at the historical changes in Florida. And so I'm hoping you take home the idea that development pressures have been occurring in Florida for quite some time, leading to significant hydrological change, which likely have impacts for downstream water quality. The knowledge of where and when those changes took place, so this historical mapping, is useful for informing prioritization for conservation opportunities. And I've introduced you to CREST, which is a geospatial decision support tool. I think it's flexible, the user designs the queries, it's objective, transparent. You'll note too, I'm not sure I pointed this out, but when I took you through the historical mapping, I really spoke a lot about the 1850s mapping, something you don't hear about very much. I wanted to kind of show you the big picture changes. When we did CREST and we incorporated it into the wetland laws, we really focused in on the 1950s with the idea that those areas that have undergone loss more recently might be the easier ones to restore, the most receptive to restoration. I also want to point out the fact that both tools, both the mapping component as well as CREST itself, are handy for facilitating dialogue and public outreach. In fact, our mapping efforts have been incorporated into an installation in the Oxbow Eco Center, which we're super excited about, as you can tell in this photo. And let's see. Oh, our next steps. So our next steps are to refine the tool. We've gotten some feedback that that we are using to make the user interface a little more friendly. And then we're expanding it a bit. Elizabeth Kelly in the Environmental Resource Division got an EPA grant to start some of the preliminary historic mapping to the 1950s and segments, particular segments in Martin County. So we're excited to start that and bring it to you guys. Thank you to our funding agencies. This work has been funded by the EPA. Some of the mapping work was funded by St. Lucie County. And a reminder in the top corner as to who we are, the Ecohydrology Research Group. And there's a QR code if you're interested in going to our website and learning more about our work.
Thank you so much, Kai. This was fascinating. And we have some questions for you in the chat. So the first question comes from Dave Fuss, who asks, are the 1850 surveys available to the public online? And if so, where can they be found?
Oh, are they available online? Can't remember. If most of our publications, we put all of our geospatial data sets on Figshare, which is totally publicly available. But our next thing and if we did that, it's at the back of that publication, the October 2023 Wetland Science and Practice will include a link to that geospatial data set. However, there's a chance that we held off because we're actually doing a change analysis based on that 1850s that we're getting ready to submit for publication. And so we may have held off and thought, okay, we'll put everything on Figshare once everything is there, including the loss layers. So yeah, I guess I don't know offhand. But it's coming. If it's not, and feel free to get a hold of me directly and I'll try to follow up on that.
Okay, fantastic. Chandler Keenan says that this was an incredible presentation. Thank you so much for sharing all this work. Can you speak to the timelines of this whole project, both the mapping and building CREST?
It was a long labor of love. We worked unfunded for quite some time. We had this great grad student who just wanted to learn about the history of the area. And so she got her master's doing a lot of the pouring through the surveyor notes. And so in other words, this was a side project for us for quite a while. We started that, I think, in 2015, honestly. And then we got a little bit of money to do the 1950s, so it's been very incremental. However, we are working on trying to automate some of the mapping, particularly the 1950s, using decision trees that we developed as we were going through the hand digitization. We kind of realized what resources we were drawing on and how we were analyzing the imagery. We're trying to incorporate that into machine learning. We've had some success with that in Alaska. We're hoping to have success here as well, in which case that mapping will go a lot faster. And so we're hoping that we can do the sort of 1950s mapping in more like 9 months or a year across a county, as opposed to this other one took a couple of years. So yeah, maybe and we have some. That's one of the things that we're going to try to work on a little bit with the little grant from Martin County. CREST itself went a lot faster. It's really the mapping that takes a longer bit. So now that we've gone through the practice with St. Lucie County, say to transfer it elsewhere again, maybe would take a year or so.
And once CREST is complete, at least to the extent in St. Lucie County, I know there's build out potential. Where will it live?
Oh, well, I need to have this conversation again, but About a year ago, I spoke with Kim Jackson, the state geospatial coordinator person, about having the state hosting it. I was hoping there'd be some state interest in this sort of stuff, and she was definitely interested. So I'm hoping that we can put it somewhere where it's easy for everybody to remember where it is and completely accessible. Right now, St. Lucie County has kind of the beta version, but we're gonna make some improvements. And
great. The next question comes from Vincent, and he wants to know if the efforts are sort of constrained by county boundaries or if they expand beyond those borders to incorporate watersheds that extend into multiple counties.
Yeah, so the reason we started with the county was simply that that was where we had the history of collaboration, and also we had started some of the legwork, some of the mapping. And so it was a natural then to piggyback Crest and have it end at the map, but that's better at the county boundary. But that has been a very artificial ending point and has kind of, I want to say, compromised or made the tool difficult to manage right at the borders. It would be a lot easier if we worked at the watershed scale, to tell you the truth.
Great, thank you. And those of you who participated before, you may notice that I launched the evaluation poll. This is for Vincent and I to figure out what topics you like, what resonate with you. So if you get 30 seconds, if you can complete that poll for us. Cheryl asks, can someone put the info share link here? Cheryl, I'm not sure I know which link you're talking about. Can you either unmute yourself or type in the chat what information link you're looking for?
Yeah, I couldn't understand the site that Kai Rains was saying. She was saying something share.
Oh, Fig Share. Fig Share. It's a
FIG.
Yes, but I'm not positive it's there. That's just like archival place. Whenever you publish your work, people nowadays want to see the data behind that work. And so whether it's Excel, whether it's map, that's that kind of thing. And so Figshare is just one of them.
I'm interested in getting a hold of the maps, the 1850s, and then the current watershed. If I wanted to access that, where would I go?
That's okay. So what I was saying is that I'm not sure that is publicly available yet. Usually we do put stuff on Figshare. We published this a year ago, so my memory's a little hazy. There's a good chance we held on to the 1850s map and didn't make that publicly available because we are in the process of publishing the change analysis that goes along with that, in which case then we would release the 1850s, the 1950s, the channels, the wetlands, and all the change layers that go with that. So I'm not sure it's on Figshare right now.
Okay, thank you.
Mm-hmm.
But I believe Kai, you said if people want to reach out to you directly when you have that, when it is publicly available, then you'd be able to let them know.
Yes, and it would be super easy. That once you know what Figshare is, it's just a matter of going in and saying, okay, download. It doesn't matter if did I post it and are we ready to post it yet? I'd have to check with my co-authors.
Okay, great.
And I can post the link for that the publication that I mentioned as well if people are interested.
Yeah, that would be fantastic. Thank you. And that is the last of our questions. So we'll wait for you to be able to post the link to the publication that you mentioned. Otherwise, want to thank you again for your willingness to present to the Water Ambassador Program and for a fascinating presentation. And I want to thank you all for participating in the program and continuing to learn more about your watersheds and stormwater and preservation and restoration efforts in the area. So thank you, everyone.
Thank you. Thank you for the opportunity.
Thanks, Kai. Bye, everyone.